As Brunel's line snaked westwards, it came to the mouth of the mighty Tamar that divides Devon and Cornwall. To build this bridge, he had to lay foundations for the central pier in rushing water 20 meters deep. Somehow, he had to find a way for his men to build up the pier from the riverbed without drowning. His plan was to float a huge wrought iron cylinder out into the center of the river, upend it, and sink it into the riverbed. Once it had formed a seal in the mud, he would pump out the water, leaving a dry chamber for his men to work in. At least, that was the theory.
Unfortunately for Brunel, he had a problem because the cylinder floated out, all absolutely fine, turned it round, sunk down onto the mud exactly as planned. But as it went down through the mud, it hit an obstruction of some kind and kicked over. And this kicking over disturbed the seal around the edge. And as they wiggled this thing down to the bottom, effectively they destroyed any chance they had of forming a good seal around it. And so what he found was when he came to clear the thing out, instead of being able to take the water out all the way down to the bottom, he got to some level and the water started coming in at him. And you can see there that the water is rushing in, and so they pumped away and they pumped away, and unfortunately the water just kept coming back in. So he could never get down to the bottom and he could never get his men in to dig the hole. And so what he does is he puts a lid on top of his cylinder. He is going to pump air into this now sealed cylinder, and pumping the air in there and putting pressure in it, it pushes the water back into the Tamar. And you should be able to see there that the water is getting pushed back. The air in there is now at higher pressure than it is outside. And so the guys can now go down inside there and work in the bottom nice and dry. When they got down to the bottom of this thing and they got into this, I think it's called a green sand dike, which is a volcanic rock, extraordinarily hard. I mean, you know, if you've ever banged a hole in your wall at home, this is, 100 times harder to hit than that. And these guys were there with rudimentary hand tools, digging 6 foot and 7 foot down into this stuff. It would have been astonishingly difficult work.
Back then, very little was known about the damaging effects of returning quickly to the surface after a long shift breathing compressed air. The men suffered terrible headaches and muscle pains when bubbles of gas blocked their blood circulation. They called it caisson sickness. Today, we call it the bends. In spite of the appalling conditions, there was no shortage of volunteers.
They were probably from the Cornish tin mines, and this was, they would have considered this the local gravy train, and they'll have come in here and got paid probably a lot more than they were earning down the pits. But nonetheless, I mean, this would have been hard work.
Once the central pier was in place, the next problem was how to carry several hundred tons of moving train across the bridge. Brunel's solution was so elaborate that it almost defeats the eye. At the heart of the structure is a suspension bridge. To stop the weight of the train pulling the supporting piers in on themselves, Brunel introduced an arch to hold the towers apart. Finally, the whole thing was cross-braced to give it extra strength. In contrast, Brunel's bridge was a masterpiece of complexity. No one ever attempted to copy it. This was not the first engineering cul-de-sac Brunel had been down. By 1846, his broad-gauge railway covered 274 miles of the national network, but it was dwarfed by Stephenson's narrow gauge, which had 7 times more track. The government decided that railways had to be standardized. There was only room for one gauge.
In the early years, it looked as if Brunel was right. But the thing that was so wrong about the system was that it was different. And the system, when it was important, everybody should be the same. And Brunel badly underestimated the importance of the uniformity of the system. There's no doubt about that. He made a very serious misjudgment on that.
Although Brunel won on quality, he lost on quantity. It was cheaper to convert broad gauge into narrow gauge, so Stephenson's gauge became the national standard, and Brunel's technically superior railway was history.
He could have been right. He would have been right. Today, we wouldn't have to get squashed as the trolley comes down the aisle. It would go faster and safer. But there were already many miles of something near standard gauge. It spread and grew and joined up. Ultimately, standard gauge won on mileage, not on science.
Brunel's broad gauge railway may have reached the end of the line, but his answer, as always, was to look for a new challenge. In the next chapter of Brunel's adventures, he steps off the platform and onto a gangplank, vowing to conquer the Atlantic.